willfully or not to let them know what their vulnerabilities are. Like many of you will be, I'm a back-end developer who can kind of tell you about the things that I've found. So I'm not an amateur pilot, but I am a jazz musician. And outside of work, I'm running a few websites and some servers. I have a lot of stuff kept online, things where vulnerabilities could be introduced. And for those of you who either are not there yet in your course at Hack Your Future or who graduated before I was there, I'm now working with Rob on teaching the databases course, which some of you are just 3 days ago graduated from. And so this intention, like I've said, is I'm assuming that you are starting your career as web developers and going to be running small applications or small services, things like you have an idea for a startup and you want to get it off the ground. You want to get your proof of concept going, be able to show people what your product is and what you want to be able to do with it. And the skills and the mindset that you'll need to be able to keep your stuff safe as you do so. So this is kind of towards the one developer or one person or a couple people working together on a project, size of project. This is not really about being a security person or a security expert in a big company or being a pen tester and things like that. It's about how to keep your own projects safe and how to keep the customers of those projects safe as well. And the thing is, I want to start by talking about some stories of things that have happened recently, things you might have seen in the news, but basically what can happen when either the attackers are just plain smarter than us or faster than us usually, and sometimes just quicker. Or just people make mistakes. We're all human. All developers are human. Code is written almost exclusively by humans, we would hope. And all these bad breaches were made, for the most part, because of simple human error by developers just like you, just like me. People introduce vulnerabilities and we don't realize, and we patch them and we move on. But now, because these things have happened, we can look back at a couple recent stories and try and learn from them. So I'm going to highlight a couple. Yeah. The Yahoo one is one of the most famous ones recently. It is so notable that it has its own Wikipedia page called Yahoo Data Breaches. I couldn't find any other companies that had their own Wikipedia page about their data breaches. So that tells you maybe about the size and scale of the impact. Basically, in last year, Yahoo announced 2 breaches that had happened in the past. The first one being the first one it announced was a 2014 breach where they lost 500 million account credentials. And the second breach that they announced happened a year prior to that in 2013. So it was 3 years before they announced it, nearly 3 years, where the attackers were able to exfiltrate 1 billion account credentials. 1 billion account credentials.
Almost every day,
yeah. That's just a lot of people, full stop. Like it was not that long ago that was more than the total number of people on the internet. And so they were able to steal things like names, email addresses, telephone numbers, encrypted or unencrypted security questions and answers. So in some cases, they were able to steal unencrypted information about resetting your password, right? If you forget your password, you go to reset your password. Now maybe you have multi-factor and you have what's your date of birth and you have email password reset links. But it could have just been, in this case, it was not too long ago that the standard was just what town did you grow up in and whatever, what was your dog's name. The problem with those is obviously they're also vulnerable to social engineering, which we can maybe talk about a little bit. But that's a pretty straightforward concept, right? If you're my best friend and I know what town you grew up in and what your dog's name was, or I can call your mother and ask, then it's not such a secure way to reset your password. But in some cases, those security questions were stored unencrypted. So just in plain text, you could just read them. We'll talk a little bit about the difference in how you store these kind of things later. And the theory, or the kind of the leading cause that at least Yahoo announced that they're aware, is that the attacker were using web cookies. So cookies, we all now, if you're in Amsterdam, you're in the EU, and when you go to a website, it says, do you want to allow cookies on this site? Okay, and usually there's not a deny option except it reroutes you away to another website. But cookies, if you're not aware, are what allows a website to remember who you are, right? So when you go to Facebook and you log in, and then you stop using Facebook and you come back an hour later, it doesn't ask you to log in again. It's one of the ways that websites remember who you are from session to session. And so the attackers were able to make up pretend cookies that Yahoo accepted, thinking that they were other people. Basically, they were able to make up their own cookies to pretend to be someone else. And that allowed them to get access to every account without using a password at all. You just have to say who you are, right? Be like going to a bar and the bartender says, oh, do you want to put it on your tab? And you say, yeah, my name is Tom. And they go, oh, Tom, all right, we'll put it on your bill for you. And you know, it's and then Tom's paying for it. And in any case, Yahoo is not the only company to have a major breach like this recently. In the past couple of years, LinkedIn, Dropbox have had huge breaches that involved leaks of customer information. And these are big companies with a lot of money and smart developers, right? They're not somebody in their basement who doesn't know anything, and they're not a bunch of kids messing around. Like, these are people who really, really know what they're doing, and it happens to them as well. Also, I mean, they're also a bigger target, right? So there's more effort going into trying to find vulnerabilities from these companies, but these are things that happen to real people, human developers, who are just doing their best, and it's just this cat and mouse game. This is an interesting article. I linked the article. If you look at the slides, this will be a hyperlink here. But this was from an article published by The Atlantic called Inevitability of a Hacked Toaster, where a researcher set up an AWS, Amazon Web Services, virtual server. Right? So he had a server, it was connected to the internet. He set it up and he opened a couple of ports, including SSH, which is the secure shell that you use to remotely connect and manage a server, execute code from the command line. So as an experiment, he set it up and he installed some software that would basically pretend to be an Internet of Things connected toaster. Why you would need your toaster connected to the internet, I cannot tell you. My toaster is offline only. But for some reason, there is Internet of Things toasters, and he connected it, or he simulated the software on a virtual server, connected it to the internet at 1:12, and it was first attacked and successfully logged in at 1:53, less than an hour, about 40 minutes. So the server was open to the internet. It was, had internet traffic just as your Internet of Things toaster would be. I mean, you want to be able to turn your toaster on from wherever you are in the world, don't you? I mean, who wouldn't want that? So he opened the server to the internet, same like the toaster would be, but he didn't list the IP address anywhere publicly. He didn't go and say, this is my server, please have at it. This is my toaster, I guess, effectively. Same like you would be if you had a toaster at home, right? It's going to be your home IP address. You're not listing that somewhere as, by the way, here's my toaster. I mean, people know what Amazon's IP ranges are, so they're being crawled all the time. People just checking to see what's available in Amazon's range of IP addresses. But one interesting thing that the author noted is when this server was breached and logged into by some attacker within less than an hour, one common thing that happens when a server is taken over is that server now becomes another point from which to attack other servers. And then when those servers are successfully logged into, that becomes the point to attack more servers. And you get this exponential increase of the surface area of the attack, of the amount of servers that can, of basically what the attack is, because it can just grow and grow and grow. Because every time a server is breached, it becomes another place to attack from. And then the last one, a little story I want to talk about, because the first one is an example of a application vulnerability with the web cookies. The second one is an example of a server vulnerability, a problem with something running on the server. This is an example of effectively a capacity vulnerability, or is an example of a denial of service attack. You may have heard the term DOS or DDoS. DDoS is distributed denial of service. Denial of service is really anything that, by accident or on purpose, takes down your website. So if you share a link or you have some really cool GIF and you put it on your website and it gets shared on Reddit and becomes the top thing and everyone's trying to access it, that was a denial of service. Your site goes down, can't handle that much traffic because you didn't expect to be super popular on the internet today. You didn't really plan for that. You got way more traffic than you ever got before. That's one type of denial of service. In this case, there was a targeted attack against Dyn DNS, which is a provider of DNS services. They're basically what many, if not almost the majority of websites around the world use to basically translate a domain name into the IP address where the first or some of their servers live. So Dyn DNS is one of these services that allows our devices to translate a domain name into an IP address and load up the website. So it's a huge, one kind of a single point of failure, or a strong point of failure, because if the DNS service goes down, you type in google.com and computer doesn't know what that's supposed to mean. So it needs to be able to translate that into an IP address somehow. So what happened is the 50,000 to 100,000 infected Internet of Things devices formed one botnet called the Mirai botnet, which you probably may have heard of, may or may not, as well as other botnets were coordinating this attack. A botnet basically being some malware that runs on computers all over the world that can then remotely trigger some piece of code. And in this case, the code was, I don't know, just send as much traffic as you can to Dime DNS. Well, they're a huge company, a huge provider of DNS, so they can really handle one laptop just, you know, hammering them with as many requests as possible. But they could not handle 50 to 1,000 or 100,000 more than they expected, and they couldn't handle somewhere between 600 and 600 gigabits per second and 1 terabit per second, which is a lot of traffic when you weren't expecting it. There was a couple attacks that happened around the same time. The first one was 600 gigabits per second. That was about a month before the main one that really made the news. And so this is an example of a denial of service attack, or a problem with capacity. So it's another way that an application gets taken offline. And effectively, the monetary incentive for this, obviously, you know, the monetary incentive for stealing credentials is obvious. The monetary incentive for taking over a server, well, maybe it's not obvious, I'll explain. The monetary incentive for taking over credentials, you can sell those credentials. People will buy them and use them for spam, or use them for whatever else. Or they'll try and see if they can reuse those same credentials on another site, somewhere where you can get money from it, like PayPal or Amazon or eBay or whatever. The monetary incentive to use to taking over a server is you can run your own software on it. You can use that to attack other servers. You can then start to sell the access to those servers. You can run expensive computation on them, which you didn't want to pay for necessarily. The monetary incentive to a DDoS attack is, you know, I'm going to call up on the phone and say, hey, I'm DDoSing you. I'll stop if you want. Send me whatever amount of money. So it's a certain kind. I mean, that's one you know, way that you can try and basically exploit a DDoS attack for some financial incentive, is effectively ransom. Because if you think services like Amazon, which rely on being able to make money by having transactions per second. So every second or every minute that they're offline is lost money for them. So they have an incentive to be able to get back online. There's money involved. So a couple things that we just want to address very quickly. Without any further ado, how many of you have a website, a server, or a web application connected to the internet right now? I do. Most, I say a little more than half. You are all being attacked right now. Guaranteed, for sure. I'm being attacked right now. It's happening to everybody. This is how a toaster gets attacked within an hour of going online. The attackers are constantly just scanning everywhere on the internet, trying to find anything that they can attack at all, and they'll figure out what to do with it afterwards. And so learning to assume that you're always under attack is the attitude that you need to be able to come up with preventative measures that are sustainable and that are, you know, kind of scalable and that can grow with you as your web app or your business or your service develops. Now, in this case, there are different kinds of security. So I'm going to talk about a couple things. Like I said, I'm going to talk about a couple things related to running a small web app, like many of you are running. But I'm not going to talk about things like, you know, corporate network security or VPNs or Wi-Fi security, access point security, and stuff like that, which are aspects of penetration testing and in general cybersecurity. But I think for the sake of you know, of who we all are, myself included, let's talk about the things that we'll need to know to keep our own application safe. So just a couple of kind of headline topics, big ideas. You know, the principle when you leave your bike at the Albert Heijn with just the wheel lock locked up, and you don't bother to lock it to a tree or lock it to a frame or whatever. You're just hoping that it's slightly too much effort for someone to come and steal it, and they'll just move on. They're just going to get bored of trying to take your bike away, and maybe someone's going to come along with a truck and throw your bike in the truck, and they'll cut the wheel lock off later. But you're hoping that either the next guy didn't leave his bike that well, as locked up as you did, so that's an easier target, or you've just made it slightly too difficult that it's not worth somebody's And for most of us that are running small services, that's going to be the case because at the scale of a small web app or a small service, you're probably not going to be attacked in terms of an exploit against your business to try and take you offline or steal a lot of credentials or have some kind of fiscal incentive. It's more going to be on the scale of really what's called the low-hanging fruit, the stuff that's easy to do. And also that means relative to lots of other security vulnerabilities, relatively easy to prevent, or at least requires a certain amount of effort and consideration. It's like the 90-10 or the 80-20 rule. We can get a lot of benefit from a little bit of effort and a little bit of consideration. And the other thing is, if you don't have to do something, then don't bother. You don't have to do something just for the sake of it. If your website doesn't require a login and storing user information, storing usernames and passwords, don't store them. You're just asking for trouble. You don't need to. If your website if you're running a blog, you don't need a login form. You just need to keep your site static, and you don't need to store that that information, because that's just giving extra liability to you to be able to store that responsibly. So it's worth thinking about if you're about to do something which poses some kind of security risk, whether that's actually really important to the functionality of your application, or whether it could be done in a different way, or a way that is a little bit lighter on its security impact. So I've highlighted a couple concerns for us, and we're going to talk about some of them, maybe not all of them, depending on time, and interesting questions and things. By the way, I haven't said this already, but if you have a question, just put up your hand, like, whatever. We'll chat about it. If I can't answer, then hopefully Juan and Daniel can. If they can't answer, then we'll come up with a pretend answer, or we'll research and find it for you. As I'm sure you have found, learning to develop software, knowing all the answers all the time is not a part of developing software. Being able to Google really well and find the answer quickly is an important part of developing software. And it's very similar with security. Knowing all the answers all the time is not an expectation, but being able to know which questions to ask is very important. So we're going to look at some vulnerabilities, things related to authorization and injection, which deal with data safety or customer safety. Basically, the being able to keep the information safe and keep your customers' information safe and maintain the trust that your customers might have in you. There are also vulnerabilities that are about availability of your application to your users, like we were talking about with denial of service, and basically security concerns related to you want to keep your application online so that you can continue to have your users interacting with it and continue to make money from it. And so we can kind of divide the vulnerabilities that we might talk about today into these categories, ones that are about data safety and customer safety, and ones that are about availability and keeping your service online. So the first one, big topic, so I'm going to do it first in case there are questions, but we're not necessarily going to do it in depth. I just want to highlight a couple of the really important points around authentication and passwords. Because if you're writing any kind of service where you want to have users interact with each other, maintain relationships between your users over time, or your users and you, there are tons of use cases where you're going to need to do authentication. If you're going to do it, that's one of the examples where if you're going to do it, we have to do it really well. Luckily, doing it really well, or at least doing it fairly well, quite well, right? The topic of the talk, fairly good security, not perfect security, but good enough, is not super complicated. Oh no, the alignment broke. Oh, that's so disappointing. I'm really sorry.
Yeah, you should stop now, I think.
I'll fix it in post. But so there's this very simple hierarchy to the quality of authentication, right? And so in general, I'm sure many of you see. How many of you use accounts for your web accounts for Gmail or Dropbox or GitHub and use the two-factor or multi-factor authentication? Better than expected. Okay, next time we do this, there will be even more hands. I can't wait. But it is a really important part because passwords may be safe, but are not necessarily guaranteed to be safe. And the whole principle behind multi-factor authentication is you get to say, is it you? All right. Is it really you? Prove it. And there's that second step that can kind of be inconvenient if you don't have the ability to do that second factor at the moment. For the most part these days, it involves basically having some kind of app on your device, on your phone, on your computer, that can use a start value that's provided by the service. They tell you, start with this big random value. And then take, every time you want to log in, take that big random value and also factor in the time and generate a small code, a 6-digit code or an 8-digit code. And that code is a result of the value that they started with, the kind of this, what's called the seed value, and the time. And you add those two together, and it can generate what it knows is supposed to be the code for that given time, and that's going to be unique to you. And the combination of your username and your password, plus this code, which is time-based and unique to you, allow you to kind of double verify, to make sure that it is somebody with access, if not you, someone with access to your password and also your device, your phone or wherever this code is being generated from. There are other factors. There are text message. You could receive a text message. You can. There are multi-factors where they'll call you and a robot will read you the code over the phone and things like that. But the idea is that it's not just a username and password. It's going to be something else that the user, ideally, that the user initiates. Now, when it comes to passwords, if these words are strange to you, I will explain very briefly what they are: hashing and salting. But the important thing is to store passwords in a secure way. Plain text passwords in your database is not even bad. It is off the charts. At that point, you may as well just publish them on your website. Just say, here are my users and here are all their passwords. Because at least then you don't have the illusion that you're keeping them safe. And to a certain degree, depending on the hashing algorithm, that might be the case with some hashes as well. And I'll explain very briefly why that's the case. And there are some applications, to Slack, you can do this fairly recently, will do magic links instead of passwords, which means if you only do magic links, the only thing you need to know about your users is an email address. You don't even need to store a password for them. You just send them an email every time they want to log in. They click the link in the email and they're logged in. That's the magic in magic links. There's no password involved at all. Of course, that has a different set of problems. It's nice for you because you don't have to worry about the complications of storing passwords. You get that for free. You're not storing them anymore. You're not responsible for the storage of them. But
yeah, for the user, actually, for the client, you're just holding him more responsibility to keep his email very, very safe.
Exactly.
And you kind of Yahoo, then he's
he's using Yahoo. He's got a double problem. Exactly. You kind of put the trust on the user to keep their email safe. Okay. So just as a very quick demonstration, so we've got, so basically a hash is some kind of mathematical function which takes some input and will output it can take an input of any length, which is important. It can output something of basically a random, what looks like a random string, but of always consistent length. It's always the same size. So you can take a password which is 3 characters or 8 characters or 90 characters or 1,000 characters, and it'll always return a 12 or a 20 or a 24, the same result every time. And what you do is you never store the user's password. You take the password, you generate a hash, and then you store the hash. And then you go, well, that doesn't make any sense. How am I supposed to check when they go to log in? The only thing I've got is this hash. I can't check if they're the real user.
comparing hash to hash.
Yeah, so you do the hash again and you check if it's the same. So you never needed to know the user's password at all. All you ever needed to do was to be able to have the same hash, and you have an algorithm which computes this hash based on input. And you just check every time if the hashes are the same.
And if I hack it and I hack the key who generates the hash.
So hashes are a one-way process because you cannot take a hash, a random, like basically the values which look random, which were generated based on the mathematical process of the input and store it. You cannot take that hash and turn it back into the original source value. It's different than encryption. Hashes are one-way functionality. Yeah, exactly. Yeah.
So I have a question about this idea. If I have a password, and for example, I have 25 hash.
Yeah.
If I use the same password twice, I will get the same hash or different?
So the whole point behind hash, I'll repeat your question. The question was, if I, and correct me if I'm wrong, the question is, if you take a source input and you run the hash algorithm and you get a result, and then you take the same source input again and you run the same hash algorithm again, will you get the same result? And the answer is yes, that's the whole point. That's the point behind the hashes. It's one way. You cannot take the resulting output and reverse engineer it to get the original, the source input, sort of. But when you have the same input again, the hash algorithm will always give you the same output. Okay? So the reason I say sort of is, if you have a hash algorithm which in computation terms doesn't take very long, it takes a few milliseconds, to compute the results of the hash algorithm, well then just take all the common passwords and hash them and save the hashes. And then when you get a dump of somebody's database, just look to see if the dump that you got from their database, what the application had stored, if that's one of the ones that you already computed. So for example, I'll take the string password or password 123, and I'm going to run the hash function on it. I'm going to remember what that is, and then I'm going to take the same. I'm going to now go password 1234. And I'm going to save the result of that. Now I know 2 hashes. So when I steal somebody's database and they've stored the hashed values, I can just check to see if any of the values that they stored, even though, remember, I can't go backwards. I can't take the hash and find out what the original input is, but I can check to see if any of the values are the ones that I already knew about. So this is called a rainbow table. It's effectively pre-computing a lot of hashes. And the problem is, computers are getting so fast that it doesn't take a very long time to do these hash algorithms. So you can compute a large range of strings and just remember what those values are. So that's what a salt is for. A salt is just a random value, doesn't matter what it is, and it can even be stored semi-publicly. It can be stored in the database directly right next to the hash password. But it's effectively another seed value, something extra which adds some more information to it, which basically means that if it's unique for every user, if someone breaks your database, they're not going to go through every user who has a unique salt as well and compute every hash they know about for every salt, if this makes sense. So every user will have a unique salt and also the hash, which resulted from the input plus the salt. So you can still compute based on their input what you were looking for, but you can't pre-compute everything because it just take too much time. You have an extra unique random value for every user. It doesn't make sense that way. If you're curious about that afterwards, we can talk about it kind of more if that was a bit confusing. But it's an important concept is basically you don't want to be storing source information. You just want to do something. You store something so that you can check the next time if it's the same. And so I just have some code which you can look up in the slides, which give a very basic example of this. But basically, if you're doing a hash, you just store the user password in their hash. And if you're doing a salt, you create something random to include in the hash algorithm, and you store that as well, so that you can still get back to whatever that was.
So we're hashing actually the random salt value plus the original plain password, and to get the kind of
resulting
data
hash. Exactly.
Okay, yeah. I was asking actually how to dehash it, but yeah, I just remember that there is no dehashing way.
That's exactly the point, yeah. And then, okay, so now that's kind of on authentication and passwords. So let's talk a bit about running a server, because this is something that many of you will need to do, especially if you want to get your applications off the ground and have them available to the public. This is really simple. As we found out with the toaster, if it's exposed to the internet, it's going to be hacked. It's going to be attacked real quick, within the hour. You can watch your logs. You can see if any of you are running a server right now, and you're not doing some kind of IP blocking or rate limiting, just log onto your server and watch the logs of auth.log, and just watch all the attempts to SSH, to log into your server, and hope that none of them are successful. And hope that none of them are successful as root, because that would be really bad. So effectively, there are a few really simple things that you can do to prevent this, which again, don't make you completely safe from every attack, but they do lock up your bicycle slightly better than the one next to you. So the first one is just not to be able to log in to a server with a password. Well, how do you log into it then? We use something called an SSH key, which is a key that your computer stores, and it sends with every SSH request and says, this is who I am, here's my key. And the server has another copy, and this is more of an advanced topic, but we can talk about it if you're interested later, come and ask me about it, that allows them to communicate securely based on identifying only from this key. So it's basically something your computer holds onto that it sends to your server and says, this is who I am without a password. And the server says, I remember you, go ahead and log in. And anybody else, even if they attempt with the password, it's going to say, nope, 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 you're not who I remember. Pretty straightforward. Not super straightforward in the implementation, but straightforward as a concept. And the other thing, SSH runs on port 22 by default. If you watch your server, you're going to be getting hammered on port 22, whether or not it's open to SSH. So simply change the port to another port, and your traffic goes down by a lot. Because again, they're looking for low-hanging fruit. They're looking for the toaster that's set up with all the default settings. Right? Don't allow root to log in. So you can, I think everyone's familiar with the command line. You know how you can execute sudo commands, which allow you to run commands, individual commands as root. Well, you shouldn't need to be able to SSH directly onto the server as root. if you can run, if your user on the server can run sudo commands, you can do everything you need to do. You can run those commands as the super user. You don't need to be able to directly log in as a super user. Just turn that off. Don't need to do it. And fail to ban is a really simple library. If you're running an Ubuntu or Debian server, just apt-get install fail to ban. And for the most part, what that's going to do is effectively it rate limits. So it says if this person attempts 3 or 5 or whatever times to log in the same 5 minutes, just going to block them. I'm going to block them for a little while, and then I'll open it back up. Still doesn't prevent it if someone's just going to keep trying every 5 minutes and waiting. But then that severely limits how often how many different password combinations they can try, and hopefully it means they just move on to another server and they forget about you. Right? The 80-20 rule. A little bit of effort, hopefully a lot of gain. You just want to be not the easiest person on the block to hack. So we move through those pretty quickly. Do you want to add something?
One comment with the previous slide. In your case, the simplest way would be just limit the IP address that can contact port 22 to your IP address, and that's already much better than by just limiting the scope. If you just limit it, for example, to the building where you're 100,000 times more secure, because all of those can also have like some kind of exploit on SSH. You need to upgrade. There could be issues with your keys and everything. But by limiting the IP address, when you're a small startup or just your computer, you're already covering a lot of ground.
That's a really good point. That's one I always forget about this, because recently, in the past few years, I moved houses like every 20 minutes, it seemed. So it's just a pain. And also, it depends if your house has a static IP address, because depending on the internet service provider, sometimes that changes without telling you. That is probably, I mean, one of the most effective things, because you're just totally blocking out everyone that is not you in that place.
But then, for like a company bigger like Google, for instance, I'm sure you have a remote developer, right? How are you going to solve it?
Well, one way to solve it would be you whitelist, like all of this, of course, but then you whitelist the remote offices, and people do VPN to those offices, and then you channel through.
Yeah.
So no longer it's exposed to internet, small scope. Of course, you need passwords and everything, but then if you're an expert on SSH, it's much harder for somebody to actually get you from a different country.
And a question, do you recommend the cloud VPN?
For example, which one?
Right, in the sense like you could have in-building VPN, but you can have also virtualize it in Amazon or whatever. So,
Yeah, like Amazon takes very good care of its security. You have other vectors of attack now. Now your Amazon account is very valuable. Somebody hacks your Amazon account, they hack your VPN, they hack your network. But with care, yes.
Cool.
But the point is that with the VPN, you can concentrate a lot of the access into a very small area. And by concentrating into a very small area, you're able to lock that area down very well, rather than trying to lock down thousands and thousands of servers. It just makes it so much easier from the maintenance perspective.
It's interesting you mentioned AWS, because that is one of the things that I'm going to mention now, maybe. There we go. So single points of failure are obviously really bad. You don't want to be in the case where one thing goes down and everything goes down after it. And one of the simplest ones to prevent, one of the simplest ones to keep safe, and probably one of the most important, especially if you are developing things open source, you're developing them open, or you're publishing your source code for part of a portfolio, is putting your, keeping the keys of the castle safe. So one of the biggest problems is just if you put your API keys into source code, or you put your credentials, or goodness, maybe your SSH key. Remember, that's the thing that your server uses to identify who you are. Well, if you put that in your source code and put it on GitHub, now everyone can pretend to be you. What a privilege for them to be able to pretend to be you.
That would never happen in our group.
Certainly not in this environment.
Wouldn't have that looking like
Yeah. So this is a screenshot that I took today. So from GitHub, I just searched GitHub for remove password. So in the first batch of search results, there were 300,000 commits recently for people that have committed their password and then realized, crap, got to remove it. stuff is crawling GitHub all the time. There are bots that just crawl GitHub. GitHub has an events pipeline, and you can just watch every single commit that's being pushed to GitHub all the time, store all the commit logs and the commit contents. So this is so not effective. Your password is already compromised. It's gone. Forget it. Change everything, right? Change your locks. Already done. Too far. And this is a fun one. This is remember we were talking about SSH keys. This is somebody's SSH key that they committed to GitHub in April 13th, 2012. It's still there, which makes me assume hopefully they changed by goodness. Hopefully they changed it by now because it's like the first search result. What does it say? SCS Lab. The S stands for Stanford, as in university. CS standing for computer science. So this is. So keep your credentials out of your source code. There are some really straightforward ways to do this. Git ignore is one of the most obvious ones, right? Git ignore, effectively, you just name a file and you say, I'm going to put all my credentials in here, and it can be anything. And then when your application starts up, you load up those credentials once they're held in memory in your application, and your source code is kept free of these credentials. Usually within minutes, hours of committing credentials onto GitHub, especially the really highly valued ones are API keys for things like Amazon, for AWS, or for DigitalOcean, or any of these cloud service providers, because with the API key, the whole point of the API key for AWS, for example, is that if you start to notice a lot of traffic, well, you can add more servers and provision them to handle the traffic, right? Netflix is doing this all the time. In the evening, when people are watching TV, they just add way more servers. And then when people stop watching TV, when they go to sleep, they take those servers down, so they pay for them by the hour. So if you have Amazon's API key, you can set up as many servers as you want, and you can bill them directly to Netflix or whoever. So if you get someone's Amazon AWS key, that's a real problem, and you can end up with a big bill from somebody who decided to spin up a bunch of servers and run some kind of expensive computation on them before you even noticed. So we'll just talk quickly, this is kind of the last big topic, about some of the web application vulnerabilities. These are the things that you just need to be aware of so that you know they exist, so that you know how to Google them to make sure you don't do them. And many of them do just involve being aware of them so that you do things in the right way. The first one, really straightforward, exposing sensitive data. This is a query string. Everyone's hopefully familiar with this, right? My great website, /profile, /user ID and password. Great, right? Perfect. In HTTPS, the query string is encrypted, but it's also going to be stored in tons of other places. Your router might be caching it. If you bookmark the page, it's going to include the query string. Your autocomplete is going to include the query string. Even if you just copy and paste this and send it to a friend, they're going to end up with the authentication of you because your user ID and your password were here in the query string. So this is one of many reasons why actions like this should not be happening over GET anyway. Login actions should be happening some other way. But make sure that you're not just really, like I said, low-hanging fruit, exposing sensitive information in a way that's super obvious. And even this way, this this is a set post or a set password. In this case, if you were not validating this information on the back end, so on the server, using something like a session, by changing the query, or by changing the query string here, so if I change this from 542525 to whatever, blah, 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 another number, well, and I send this, if you're not validating that this is actually being sent by this person, I could change the password for whoever I want. I can change everyone's password. So that's, even though it's being sent through posts, hopefully slightly more secure, I'm not putting the new password in the query string. But if I'm not validating this in some other way, then I could end up with a huge vulnerability, a big breach. This is one I think many people will probably be familiar with, is SQL injection. It's really straightforward. If you've done databases, apologize if you're not doing databases yet. Come back to this slide when you've started working on your databases stuff. And if you're in the Hack Your Future class that just hasn't gotten to studying databases with me, we'll do it then. Really simple, right? We're doing string interpolation. We're going to say, select something from customers where name equals, and we're going to add something in here, right? And we're just going to fill out the string and add it all up, sum it all up. And we've got the input, but I'm going to make the input include the quotation mark that would end the string, and then I'm going to add some extra stuff in here. And when JavaScript puts this all together, this is going to become like this, where name equals whatever. Done, end query, don't care about it anymore. Drop table customers, that's really bad. So you have to be doing something in here to either escape or validate or manipulate this input so that it does not cause a problem in your database. That's a huge one, really important one to be aware of because it's really easy to get wrong. This is a simple one. Sorry, it goes off the screen a little bit. So there's a dating website called Plenty of Fish who had an example of this vulnerability not long ago, a couple of years ago. So cross-site scripting is effectively if I can make some string a value that is important or readable or parsable by HTML, and then I can put that on a web page which is loaded by someone else, it's going to execute that. So in this case, I'm appending you in here. I'm going to make this div, and I'm assuming it's going to be a customer name, but maybe the customer's filled in a script tag. And now this script tag is going to be executed by the page that loads this. Super, super bad. So what happened in the case here is they, so somebody, basically what I'll do is I'll just fill out my dating profile and say, my name is Jason, script, SRC, whatever. And now everyone who visits my dating profile is running whatever code is in this script. So I can be grabbing whatever I want. I can track user behaviors. Do you remember in the early days of Facebook, you used to be able to install apps and extensions and stuff that would tell you who had visited your profile and stuff like that? It's effectively a very elegant form of this. It's executing code on your page load for other users. This is just another vulnerability. Again, this is one that's probably going to happen to particularly high-value websites. So I've got my malicious website right here, but it doesn't look like my malicious website. It looks like Google. I am embedding the Google web page in a frame, and the border around it is my website. It's like a 1-pixel border, whatever. I've highlighted it to make it clear. And when you click on this next button, I put an invisible button over it. You can't see it, but I put a button over top here. And when you click on it, it's going to do something else other than what you expect. I can make it do anything I want. I could make it like my page on Facebook or follow me on Twitter or whatever, or something else. But this is a way of basically taking the UI of somebody else's web page, and when you try and click on something on the web page, stealing that click to do something else, hence click jacking.
Just one question with regards to the cross-site scripting.
Mm-hmm.
Like in terms of what we would have in our real lives when we're coding, where would you mostly see this happening? Like in a forum, or what would be the obvious way to do this cross-site XSS? There's
tons. Forums are an obvious one because you remember you used to be able to do signatures on forums and stuff like that. So you could just add some tracking code to your signature. Forum signatures years ago used to allow HTML on purpose so that you could add whatever sparkly things and whatever you wanted to your signature. But then that's being executed by everybody's browser. So that's one example. Yeah.
Just one question. Where would be like the best place to validate for cross-site thing, like on the front end, or after the data will be sent to the back end and the API will handle the request, they make validation on the data, on the string. Then it has to be sent.
So the question is, what's the best place to validate the input? I mean, the best place is everywhere. So this can occur in a couple different ways. It could be like in the case of the dating site where they were actually storing in their database this string. So it was being pulled from the database and shown to users on every load. So in that case, similar to SQL injection, we could be escaping it into different characters on the way in. But on the way out, we also want to be escaping it for those characters. So basically what we can do when you escape the text when you send it is HTML, or not HTML, sorry. Whatever you're using to escape it will turn these characters, which mean something, that have semantic information. They'll turn those into the equivalent HTML special codes, which the browser will know to show this, but won't run it as HTML. Right? It's like the white space in HTML is ampersand and BSP.
Character entity.
Yeah, exactly. So you have some kind of escaping, which will change these characters into the symbols. So basically instead of running this code, it'll just say that for the person's name. Right?
Can I just answer that?
Please.
This is a pet annoyance of mine. If you're gonna try and deal with cross-site scripting like this, always escape when you're rendering to the final output. Don't escape when you go into the database, because when you go into the database, you never actually know where you're going to render something. You know, the data that you're storing in the database can end up on a web page, it can end up on a mobile device, it can end up in an email, and the only way, or it can end up in the div of the HTML page, it can end up in the URL. Each of these contexts is slightly different encoding requirements.
Yeah.
So when you're going to try and deal with this, just always escape everything that you render to wherever you're rendering. In the HTML, then always HTML escape it. URL encoded. And that's the only consistent way that you can make sure that you don't mess things up and make things too difficult. So, a lot of people decide that they'll escape when they go to the database because just escape it once, you're done everywhere. As soon as you try and have a mobile application, then you need to try and undo that as soon as you try and render it within the mobile app. And then you're in for a world.
So we can say escape all the user input.
Escape all the things.
Escape all.
But specifically,
escape all the variables.
escape it on the way out
Yeah.
when you're rendering it with the thing that you need to be escaping for.
Yeah.
So,
Just
because
escape all variables. It's the blanket rule. In a lot of cases, in a lot of the modern frameworks, if you're rendering a variable, it will automatically get escaped for you. In some cases, you can turn that off. Don't. So you're in trouble. It's better to go for the approach of disabling escaping on a per variable perspective rather than at the framework level. And then for the most part, you'll be okay.
So in your experience, do you also try to implement CSP? Well, I'm just saying
Yes.
this because we just get out from some issues with it. And do you enable it to not inline script?
So it depends on what your application is and what you're going to want to be able to do. CSP, for the rest of the question was, do you enable CSP or would you enable CSP? And CSP stands for Content Security Policy. It's an API that the browsers provide that you send information in the headers of the page saying this is what I want to be able to happen on the web page. So in the case, so this would be like an inline script, so a script in the, or a script tag, whether you want that to be able to execute, whether you want embedded frames to be able to execute, whether you want resources to be able to load from other domains. So for the most part, I mean, so the thing with these browser APIs is because there's lots of browsers and it happens over time and people don't update their browser as soon as it comes out, except for Chrome if you have the auto update on. The support is not always going to be perfect, but you can get a lot of benefit by enabling these things. And so for the most part, I would say if it doesn't affect the functionality, it's not going to cause a problem. It doesn't hurt to have it on and keep your website that a little bit more secure. However, it's the same problem with the escaping is you may find that you need to reevaluate if the needs of what you need to be doing change. But I was running around now. But yes, that's why there are other browser security headers as well, which is related, similar, separate to this in particular. But that's like a configuration. I don't know. Does that make sense?
There's many headers. You just need to enable as many of them as you can. There's a website called securityheaders.io, and it's always a good starting place for essentially use of the base URL for your website. And it just has a look at the headers that you're using. And then it tells you which headers they think you should be using, which ones you're not, and which ones you are, and gives you a kind of a rating. They're just trying to essentially use all the headers that are recommended, and you're good to go. But it takes effort at times. It means that you have to be a little more diligent in order to be right. What functionality that you use.
But yeah, so if this is I'm glad you asked about this, guys. It's an important one for sites where users interact with each other. Yep, talked about iframe. So this one is the remediation is slightly more complicated, but the vulnerability is fairly simple to explain. This is cross-site request forgery, which is, so I'm going to load up this website, malicious.com. I don't know, I get accidentally redirected to it or something. It loads up in a pop-up or something like that. Or it's a good website and it's had some exploit. But then the next thing that happens is this malicious.com website, as soon as it loads, it's got a piece of JavaScript. It's got some AJAX, which is going to run this get command. secureimportant.com/profile/change password, and here's my new password. So because if this GET request is sent by an AJAX call in the JavaScript that was being loaded by malicious.com, when this GET request to secure important gets run, it's going to get run by my browser. It's going to get run as me.
So if there is cookies actually.
If there's a cookie or a session, it's going to execute as if it was me. So the problem is that basically the vulnerability here is that when web apps like secureimportant.com trust that any action that comes from the browser, identifying the browser based on cookie or session, is actually the user and what the user wanted to do, which may or may not be the case. It's another example of why you should not do things like change password in a GET request. But in an attack, the action is taken by the user's browser, but by a remote website, by the attacking website. So malicious.com is just going to collect people's passwords. It's just going to keep changing people's passwords every time they go to this website if they were already logged in to secureimportant.com and still had an open session. So different than some of the other vulnerabilities, this one doesn't, this is an exploit on the trust that apps have in the browser to be who they say they are. Okay, so those were the web vulnerabilities we want to talk about. I know that was a lot. So we'll just quickly talk about capacity planning. This is really simple. If your website starts to get a little bit bigger and you're worried about your one server being taken offline, remember we talked about single points of failure. If you have everything running on one server and that server goes down or gets attacked or even just has maintenance or the data center where it's hosted loses, has a thunderstorm or something, your service goes down. You're no longer serving traffic to your customers. So this is a really simple chart for application resiliency. It's just if you need something to point your internet traffic at. Your DNS needs somewhere to send all of the traffic that for requests for your site. And then you can distribute that traffic evenly wherever you want using something called a load balancer. And often this is bundled or included with a reverse proxy. And a reverse proxy basically is part of the load balancer, but it pretends to be all of the other servers as well. So the load balancer is able to distribute traffic to all your other servers, and then it sends it back to the load balancer, and the load balancer sends it back to the user saying, that was me, I did that. So effectively pretending that all of your traffic comes from the one server. But behind the load balancer, you can do whatever you want. You can have multiple application servers that point to the same database. You can scale that out even further and further. And you can have a staging server where when you're trying to test new code, you add this to be part of the load balancer, so it's getting now 1/3 of the traffic, and you see if there are any problems. And then when that works, you can then take the app servers out of the load balancer one at a time to keep your application running and keep it up all the time, so you don't have to lose you don't have to have any downtime. You don't have to lose any traffic while you change the code or add new code to your servers. And this is a really simple way that, if one of these application servers goes down, your service is still up. It still has points of failure in the database and the load balancer, but it's going to be significantly more resilient, especially if you start to scale this out across different places in the world and stuff like that. But this is kind of definitely the next step up from just one server running everything everywhere. And that's most of all of the topics I want to talk about. It ran a little bit longer than I was anticipating, but I'm glad we got to chat about some of the things. So now, please ask all of your questions, and if I will try to answer them and hopefully succeed at some of them.
Well, I have very similar thing. I just read recently, but the headline actually, it was about the primitive exploitation. So for example, for the backend, when you're running your code, and sometimes you're asking the user to specify the format for given string by the primitive. So do you have an idea how that could be a kind of exploitation to your program?
I can sort of understand what you're getting at with the
Which is
so like the printf
printf,
the printf statement has two parts. The first part is the format specifier,
yeah.
but the vulnerable thing would be if this format specifier is put by a user, so he can run like his own code in it.
So it sounds like you're describing what's like
Is
a
it
remote
similar
code
to-
execution. where you could basically break out of the application and run any other code.
So is it like similar to the cross-site scripting?
Sort of, it's
But
closer
the
to the
back-end
injection.
Or
It's
injection?
more, yeah, but effectively it's, you send some input which the application wasn't expecting, and it tries to handle it and fails in some way.
Okay.
I think what he means is the shellcode exploitation, where you have a lot of hexadecimal values and you can put it, and then it will be expanded and the code will be run. It's a shell code you have to write. So it's a sequence of bytes, and that will be converted into system calls, and you can also execute processes. And you can do crazy things with shell codes with the printf.
Yeah. And the,
There's a very well documented white paper in the late 90s on exactly this. And it focused on the fact that the way that C code particularly works is that you can kind of overflow buffer, and you can make the code execute instructions that aren't really part of the flow of the program itself. And then if you can work out ways of doing them creatively, then there's all sorts of things that you can do. Overriding memory, putting instructions into the memory that then get executed later on because there are other issues. I can't unfortunately remember the exact name of what this particular exploit is. Others have pointed to a whole white paper, massive discussion on this, and there's a lot of very interesting literature on it.
with these kind of things, one of the ways to remediate that, to prevent that, is to validate the user input to make sure it's one of the things you're expecting.
Yeah.
So if you're expecting that, if it's something like an encoding, if you're expecting it to be one of a handful of values, you just check if it's one of those. So it's, you validate the user input to make sure it is either of the type you're expecting, right? If it's supposed to be a number, that it actually is a number, or if it's one of just a limited set of values that you're expecting.
No, that's actually a very important point. You can avoid a lot of these problems by just verifying that the thing that you have is what you expect. If you're expecting a date, make sure it's a date. If you're expecting an address, make it an email address. If you expect it to be a number, validate that it's a number and it's not rejected. And that way you get around a lot of the injection, a lot of the XSS, a lot of the SQL injection, a lot of the whole class of stuff goes away, and your data actually is useful, as opposed to having a lot of random stuff in your database that you can't do anything with. And then, worst case still, later on you're trying to use that data, and then you have to put in all of these workarounds because the data that you have isn't actually what you expect. You need to jump around in hoops and try and cater for that. So the data sampling on the way in just makes things a lot easier for the long run. It's a little bit extra effort, but it's definitely worth it.
And it's related to just thinking about things in this way, that rather than trusting that your users would never put something that's not a date in the date field, just assuming that they absolutely will. And so you just think that that's going to be the case. So you get ready to prevent it. It's a simple way to address lines.
I do have a question. So, well, we talk about attacks indeed, but since you mentioned also remote code execution, reminds me that recently, I think more than a year ago, Image Magic, that is basically one of the most likely installed dependencies in servers. You want to do image manipulations, had a big execution, so you can load images and remotely execute code. So at this point is how you manage the security that is broken in your dependency.
When you trust a dependency, something like that, a remote dependency, you effectively are trusting it with the security of your system and of your customers and of their data and stuff like that. It depends on how deeply you use the dependency, but you are effectively trusting it as much as you trust your own code. Sometimes these things, when these things are open source, and there's hopefully the whole point of open source is that there's more than just a couple eyes. There's a lot of eyes watching the commits and watching the code to make sure this kind of thing doesn't happen. But in the world of NPM, where you can just NPM install any functionality you could ever desire, there is a risk that that code is not open source and that was just written by somebody who could have malicious intent. So if you would be reviewing your own source code to make sure that your own developers aren't introducing these kind of vulnerabilities, you want to be reviewing any dependencies as well, just to make sure you can trust it just as much as you can trust your own source code.
Yeah, on this exact point, anecdotally, if you ask any security professional what they spend the majority of their time on, it'll be upgrading packages.
They would
Upgrading packages, because you have to review them.
There's a massive amount of time and investment that goes into For example, Booking.com, where we have thousands of servers, upgrading servers, upgrading versions of stuff on the server, upgrading image methods, upgrading OpenSSL, upgrading random Perl libraries and modules because something will find vulnerability. It allows for execution, you have to upgrade. And it's a lot of monitoring a variety of feeds that will let you know when there's a vulnerability found, as well as a lot of very active scanning from a security perspective that constantly pokes all our servers and tries to poke holes into it. And if anything is successful, then we fix it. But it's a massive ongoing endeavor. There is no easy fix, unfortunately. It's just one of these skepticisms.
Yeah,
It's like 70% patching.
There is only cure and no prevention.
And the prevention as well.
Yeah, so in this context, if you have your startup, I would say that you can trust your dependencies and keep it updated. But when it's viable, you would consider that security is based on layers, and getting into your machine and executing code with that, there should be also other layers. So you will want to monitor your machines. You will want to know what kind of processes happen. You will want to have good logging on it. Of course, that if you have your own startup, you could be very paranoid and do all of this, but you might spend more time on that than actually developing a product. But on a big scale, you should consider that you're going to get on pretty much. So things get updated once they're exploited on the wild for long enough that people actually recognize it, see that people are exploiting, then they patch it. So there's always a lot of people that get exploited with this, even patching religiously all the time. So you should have more layers there, which is monitoring, logging, maybe the application boxes don't need to access the database. Maybe they communicate to APIs which have less dependencies and all of that.
That kind of also goes back to Jason's earlier points of just, if you don't need it, don't have it. And from my perspective, as well as, if you don't need to have a whole bunch of ports open to the world, don't have them open to the world. You kind of reduce the entry points into your system. So with Image Magic, for example, it's something that can be pushed in, but there are a lot of exploits that require access to the box or access to a particular port. So don't have those ports open. If you can reduce that surface that people can poke at to only the bare minimum that you need to service customers, then you're already a long way. It's a big step forward.
So isolation also.
Yeah.
In order to
Yes.
And so next to that, I think, for example, Amazon nowadays provides a service that provides security advisory.
A little bit. I think they do active scanning with a security scan called Nessus. That essentially.
Yeah, but they even have service that goes into your security system, checks which packages are installed.
Yeah, so that's what I mean. That's Nessus. So Nessus is one of the security scanners that essentially looks at the box and sees what's installed, and compares that with a list of known vulnerabilities that it knows about and exploits that it knows about. And if you have a version of something installed that it knows is vulnerable, it will stay with it. So I'm pretty sure Amazon does that these days. We do that ourselves. Amazon does that for you as well.
No, but you have a service where you can trigger yourself a test.
Yeah, exactly. That's what it is. It's a scanner that sort of looks at your box, pokes it, sees what it can find, and it will let you know if it finds anything that it knows has a problem.
And as well, for example, with PhD practice, there's also something like security. Yeah, in the end, you don't find everything.
Yeah.
Gives you one extra layer of.
There's a lot of information about existing and known vulnerabilities on the web, and a lot of the scanners, even some of the open source ones, will just have a look at what you have installed and then compare that against what it knows about, and that goes on massively. Now, whether or not you can actually then upgrade without breaking your functionality, it depends on which parts of the functionality you use. Hopefully that goes a little bit away from answering.
Yeah, question.
There's another question besides security for open source projects. Some startups, they host their code on GitHub or any like Git version control, Bitbucket or GitLab. But some other companies, they also use like their own servers to store code, like to run their own local Git server. So which one like would be more secure than the other?
Both have very different security concerns. If you run your own Git server, because I mean, if you have private Git repos hosted for your company on GitHub or something like that, where it's remote hosted, it is effectively they run the remote server for you, and that then your single point of failure is anybody's credentials that have access to that, or whatever the main credentials are to log into that server. If you run your own Git server, now you have to do all the work. You have to do all the work of keeping it secure. You need it, either like firewalled or maintained away from what any unwanted traffic, same like we were talking about with SSH. You have to keep it away from any traffic that you don't intend. But you aren't exposed to any vulnerabilities or phishing campaigns that might target specifically people that are using GitHub. We didn't really talk about phishing or social engineering because it's more of a people using computers thing than it is an application vulnerability thing. But so it exposes you to a different class of problems. And it depends on who your developers or who your ops people are, which set of problems they want to pick. Does that make sense?
So let's say I want a career in security. Where do I start, and what is the normal path to work your way up?
Not to ask these guys more
Why
than
did
you.
you get into security?
So I get serious. So I started working at Booking.com as a developer and was asked what teams I wanted to be on, and application security was looking for developers. So I said I would like to learn that. And on my first day, I showed up and I said I was having lunch with one of the guys on the team, and he said, I said, so what is it that the team's doing mostly? I mean, I've got to assume like a security team at a big company like Booking.com with tons of developers, like I've got to assume it's like, the cryptography and the hashing, like the really deep stuff, like the intense stuff. There's no way that you guys are just working on the level of SQL injection and all that kind of stuff, because for sure all the developers are already aware of that. And he looked at me and went, there's that stuff too. And the reality is when you have so many developers and you have a lot of people working on a shared code base, you're inevitably going to end up with vulnerabilities introduced. And so it's a lot of being able to recognize and mitigate these kind of things. But I mean, it probably like, my first encounter with security was running my own server and watching SSH get hammered and going, I should really, really change my settings for the SSH port on this server. And then just following an interest in that. And luckily there's tons of documentation online. There's even resources to get started with things like penetration testing. And didn't mention pen testing that much, but you should probably only pen test people if you have their permission and they're very happy about it. You should probably not pen test anyone you want because they may not be very happy about it at all. But there are resources to learn about these kind of things, tons of documentation online. I can share some links around things like OWASP, which is this very comprehensive resource about different vulnerabilities. That's where a lot of the information that I shared about vulnerabilities comes from, along with examples and remediation techniques, so ways to prevent it, that kind of thing. So luckily we live in an era where lots of this is available, and a lot of the stuff we talked about, I mean, none of the stuff we talked about, except maybe hashing, involves any math or cryptography. Hashing also, for the most part, almost every security developer is not really writing, hopefully not writing their own hashing algorithm, because you are almost guaranteed to not be able to write as good of one as whatever open source one there are, and because hashes are one way, someone else writing it is not a blocker for you using it. So yeah, luckily there's just tons of resources to start. And I would say the most important thing to get started with is take whatever service or server you're running and try and make it more secure than it is already. My servers are certainly not the most secure. So it's being a little bit better about these things tomorrow than you were yesterday. How did you guys end up?
Just went to a job in security, then infrastructure, then I'm in security. But I guess there's two big profiles there. You either like to break stuff or defend against people who like to break stuff. If you're able to spot on which one you are in the beginning, that's awesome. You will always learn a bit of the other, but people do have very good either they're very good finding flaws or defending against flaws. And in general security, I guess it's a bit of knowing about everything enough, and then being able to actually go deep enough in some aspects, which actually then return into what is security. So, for example, knowing about networking, infrastructure, Linux, all of this stuff will help you in security, but also just trying to break stuff. So there are a lot of virtual machines which you can download. They are full with different vulnerabilities, and then you can start exploiting them and learning, especially learning how the exploit works, and going the other way around. So you find an exploit, you can execute it, you can see what's happening, and then you start learning about, okay, what's a shell code, how does this happen, how you can bypass a firewall, that kind of stuff. Okay.
Okay, I have a question. Can you give few names of some of the security scanning tools for on-box and for remote?
Yes, and a lot of them, it depends on whether or not you want to pay money. There are, right, so the free ones. So do I use, I don't believe I have any automated scans running on the servers that I run by myself. We at Booking use a few. I'm not sure which ones are free or open source.
I might be a bit outdated, but the ones I used to use a lot is OpenBus, would be like Nessus, but free. Then you have one which fits called Nikto, W3AF. For SQL injections, you have SQL Map. For WordPress, W3 Scan.
I'll ask Juan to write them down and we'll send them out.
Yeah,
No, I'll send it to everybody.
there's a website that collects the best security tools, and they have a button for scanning. So basically, just Google the top security scanning tools, and there's a lot.
Can we also say that just use Kali distribution?
Kali
Well,
Linux.
it has a lot of them inside. Yes.
Yeah.
And you can just look.
For everyone who's curious. So Kali Linux is an operating system you install which comes with tons of tools for scanning and security testing and this kind of thing.
Kali is more like remote. It's a remote. I'm asking about there are some tools that install on your server, and this kind of packages that you have to install.
Oh, okay. I'm not sure if OSSEC provides some scanning.
Something like that.
Yeah.
I think next time.
Yeah. But yeah, basically you're looking for agents.
People around for open source security scanners, so kind of like agents. They will come up with a good one.
Yeah, and send some around. Okay.
That goes more into the host-based ideas stuff.
Yeah.
But basically, there are tools that you can install in your box, which are going to monitor your box to make sure that you have the latest patches. They monitor your logs to see there's nothing anomalous. For example, a connection from a different private key, or somebody is trying to modify some files that shouldn't be modified, or there's a process that looks like some kind of rootkit which has been found in the box. Those are usually host-based IDS. The IDS stands for intrusion detection system.
Any other questions?
There any question more? Would like to
Okay. Well, we'll stick around for another beer. So if you have more questions, I hope I will at least come up and ask. And if there are resources, we'll send stuff around in Slack or to everyone. And if you like, I can provide these slides as well, and we can add some notes and stuff to them so that to keep them a bit more up to date with what we've talked about, so that you can use it as a bit of a reference. But hopefully you can all now understand a little bit more about what some of these vulnerabilities are and keep your own applications and your own servers a little bit safer. And yeah, come and talk to us if you have any questions, and work on your apps and get them going and keep them safe. Cool.
Nice.
So I just close because I want to thank you, a couple of people. So first of all of you, indeed, Aki Fisher, Most of you are IQ Future. And then Jason, of course, amazing presentation. Thanks for introducing us to the topic. Guys, thank you from Booking.com to have a support Jason, but also like expand the topic itself. And yes, let's stick around for a few beers more. And thanks Insided for offering them. Also the pizza, please finish them because we don't want our rats jumps around. And this is really important. Thank you so much.